welcome to Unit 7, Lesson 1. We are going to be talking about quadratic graphs and their properties, mostly focusing on whether or not they open up or down and how wide or narrow they are. So to start off with the warm-up, we are just going to be evaluating expressions where x is -4, y is 3, and z is -2. So if I have xy squared, I would plug in -4 for x. And then for the y, I'd plug in 3. And so then, because we have to follow order of operations, we would have -4 times 9, because 3 squared is 9. And then -4 times 9 would give us -36. For number 2, xz squared, we would plug in -4 for x. And then for z, we would plug in -2, so -2 squared. And then following order of operations, we would do -2 squared first, which would give us +4. And then -4 times +4 would give us -16. For number 3, 1/2 x squared minus y, we would have 1/2 times x squared, which would be -4 squared, minus y, which is just 3. And so then squaring that -4, we would end up with 1/2 times a +16 minus 3. And then since we have to take half of 16, that would end up just being 8 minus 3, and 8 minus 3 is 5. Okay. And then for the last one, -1/3 y squared minus z, we would still have that -1/3, but we would plug in 3 for the y, and then -2 for the z. And so then when we do that, 3 squared would give us 9, and so we'd have -1/3 times 9, and then the minus -2 would actually become a +2, because when you have two negatives, they become a positive. And so then -1/3 times 9 would give us -3, because remember, -1 times 9 and then divided by 3. And then -3 plus 2 would give us a -1. So we're going to start just by graphing some equations. This first one is in slope-intercept form. In case you don't remember that, that is your y-intercept is your b, and so we would come down to -3 on the y-axis, and then this number is your slope, so we would rise 2 and run 1. So we'd go up 2 from our y-intercept and over 1 and plot that point and draw our line, like so. Now, if I had something like number 6, it's an absolute value, so I can make a table of values. And usually when we do table of values, we want to use -2, -1, 0, 1, and 2. So if I plug in -2, I would have the absolute value of -2, which is just +2, plus 1, which is 3. If I plug in -1, I would have absolute value of -1 plus 1, so that would just be like 1 plus 1, which is 2. If I were to plug in 0, that would give me 0 plus 1, which is just 1. When I plug in 1, though, you notice I end up with getting 2 again, and if I plug in +2, I get 3. So then we would plot those points. -2, 3 would go left 2 and up 3. -1, 2 would go left 1, up 2. Then 0, 1, 1, 2, and 2, 3. And so absolute value graphs actually look like little V's. Boop. And so for number 7, this is going to be our first actual quadratic, but we would have x, y, and again, we will still just plug in -2, -1, 0, 1, and 2. So starting off with -2 being x, we would have -2 squared, which is a +4, minus 2 would give us a +2. Then if we plugged in -1, -1 squared would be +1, and then 1 minus 2 would be -1. Then if we plug in 0, 0 squared is still 0, and minus 2 would be -2. Then when we plug in 1, we would have 1 squared, which is 1, minus 2, which is -1. And then when we plug in 2, 2 squared is 4, minus 2 is +2. So again, we're just going to plot those points. We'd go left 2, up 2 for -2, 2. Left 1, down 1 for -1, -1. For 0, -2, we would just go down -2. And then at 1, we'd be down at -1, and 2 up at +2. And so the thing that's different with parabolas is that they actually make a U shape, and so you do kind of want to try and curve the graph as best you can at the bottom. So comparing our quadratic graphs, we have different transformations that happen to them. So if we start with y equals x squared and y equals 3x squared, if I were to graph the y equals x squared, I would start out at 0, 0, and then this graph, when I plug in 1, would go to positive 1 because 1 squared is 1. And then at 2, 2 squared is 4, and so it would come up here. And I would get the same result if I plugged in negative numbers. So my regular y equals x squared graph is this blue parabola that you see. Now, if I had y equals 3x squared, that's going to make it a little bit different because when I plug in negative 2, I would have 3 times negative 2 squared. Well, negative 2 squared is positive 4, and positive 4 times 3 is 12. And so then, if I plug in negative 1, we would have negative 1 squared, which is positive 1, and positive 1 times 3 is just 3. If we plug in 0, we would end up with 3 times 0 squared, which would just be 0. Then if I plug in positive 1, that would just be 1 squared, which is 1, times 3, which is 3. And then when we plug in the 2 again, except positive 2, that would be 3 times 4 again, so that would give us positive 12. And so with this graph, we'd have 0, 0, so that's still the same point, and then negative 1, 3, and then 2, 12, which is just off the graph altogether. Okay, and so you notice when you have a number in front, having a number like 3 in the front made this actually get narrower than the original. Okay. So if I had something like y equals negative 1, or not negative, if I had something like predict how the graph of y equals 1/3 x squared would be similar and different to y equals x squared, think about it. A number going above 1 made it go narrower, so a fraction would make the graph go wider. And so if we actually graph those points, I could make myself a little table if I needed to, but negative 2, negative 1, 0, 1, and 2. And if you haven't noticed that these are just mirror images of each other, at when x is 0, x squared is 0 times 1/3, which is still 0. When we plug in 1, 1 squared is 1 times 1/3 would be 1/3, and then 2 squared is 4, and 4 times 1/3 is 4/3. And so it would be the same numbers over here because parabolas are the same on both sides. You just have to find that axis of symmetry, which we will talk about here shortly. But what ends up happening with this graph is that it's taking longer for it to actually open up, because it does not even get above 1 until it's already out 2 on both sides. So it does indeed make the graph go wider. So if we look at y equals 2x squared and y equals negative 2x squared, this is going to be a different scenario that we have, but we can make a table of values, and we will do x and y equals 2x squared and y equals negative 2x squared. Let's make a nice big chart. So we're still going to use negative 2, negative 1, 0, 1, and 2. So if we plug in negative 2 into the purple 2x squared, negative 2 squared would be positive 4, times 2 would give us positive 8. Negative 1 times negative 1 would give us a positive 1, and positive 1 times 2 gives us 2. When we plug in 0, 0 squared is 0, times 2 is still 0. 1 squared is 1, times 2 is 2, and 2 squared is 4, and 4 times 2 is 8. So again, those numbers are just repeating. If we plug into negative 2x squared, When we plug in 1, we would have 1 squared, which is still a positive 1, but positive 1 times negative 2 gives us negative 2. And then if we plug in 2, that would be 2 squared, which is 4, and 4 times negative 2 is negative 8. And so these numbers would end up being the same on this side as well. And so if we were to graph them, 2x squared would be at 0, 0. And then, oops, have my purple pen, there we go. So 0, 0. Then I can go over to 1, 2, and 2, 8. And then I can do the same on the other side. And so the graph ends up looking about like this. Whoop. And then if I graph the other one, negative 2x squared, I still have that point at 0, 0. But then at 1, I'm going to be going down to negative 2. And at 2, I'm going to be going down to negative 8. And so if you notice with these graphs, the only difference is that it flipped the blue graph down below the x-axis. And causes it to open down. So in order to tell if a graph opens up or down, you look at what's in front of the x squared. And that, another fancy word for that is just coefficient. Coefficient. Okay, and so that means that if I have negative 2x squared, that's going to open down. Okay, so graphing the equations x squared minus 3 and x squared plus 3 on the same coordinate grid, if I have just the y equals x squared, that's going to be, hold on, and actually we will have x squared minus 3, x squared plus 3. Okay, and so still plugging in the same numbers, negative 2, negative 1, 0, 1, and 2. Starting with x squared minus 3, when we plug those in, oh goodness. Boop. When we plug in negative 2 squared, that would be positive 4, and positive 4 minus 3 is 1. When we plug in negative 1 squared is 1, minus 3 is negative 2. 0 squared would be 0, minus 3 is negative 3. At 1 squared is 1, minus 3 is negative 2. And at 2, that would be 2 squared, which is 4, minus 3, which is positive 1. And so then for the other one, when we plug it in, negative 2 squared would be positive 4, but plus 3 would end up at 7. When we plug in negative 1, that would be 1 plus 3, which is 4. 0 squared is 0, plus 3 is positive 3. 1 squared is 1, plus 3 is 4. And 2 squared is 4, plus 3 is 7. And so when we graph these two on the same graph, we have 1, we're at negative 2, it's at positive 1. At negative 1, it's at negative 2. And at 0, it's at negative 3. And then it comes back up like that. Okay? But if we have a graph like x squared plus 3, at negative 2, it's going to be up at positive 7. Then at negative 1, it's at positive 4. Then at 0, it's at positive 3. And then it makes its way back up. Whoop. Like that. And so notice from those, when you add or subtract a number, what's happening is it is making the graph shift up or down. Okay? So when you add a number, that is going to make it shift up. And when you subtract a number, that's what's going to make it shift down. And it just shifts straight down on the y-axis. We'll get into left and right shifts later on. So, move the graph. So, moving on down, with your rules for a quadratic function, if it's in standard form, y equals ax squared plus bx plus c, If a is positive, then your parabola is going to open up. If it's negative, though, then your parabola is going to open down. Okay, so opening down would be something like that, and opening up would look like that. And so then, if the absolute value of a, which is your number in front of the x, if that number is bigger than 1, then your parabola is going to be narrower. Okay, so bigger than 1 is narrower. And then if it's smaller than 1, then it's going to be wider. And keep in mind that smaller than 1 means that it is a fraction or a decimal. Also, keep in mind that a negative number does not affect how narrow or wide it is. The negative number just makes it open down instead of open up. Okay, so with quadratics, your parent function is your simplest quadratic that you can have, which is y equals x squared. Okay, and with a quadratic, your vertex is going to be your lowest or highest point. So that's going to be your maximum or your minimum. Minimum, highest point is your maximum. And then your axis of symmetry is going to be the line that goes through the vertex and divides the parabola in two. Okay, and so if we look at these two examples, with this first graph, to identify the vertex, I'm just looking for where it turns. So you just kind of ride the parabola down, and as soon as it starts to come back up, that is its vertex. And so this vertex is a minimum because it's a low point. Think of it like a roller coaster, and it is at -4. And so my axis of symmetry would be at x equals 1, because remember, an x equals equation is a vertical line like that. And so the number for your x value of your vertex is going to be the same as the number that you get for your axis of symmetry equation. Okay, and feel free to label that if you need to as the axis of symmetry. Okay, and that is always going to be x equals something. So for B, doing the same thing, looking at the parabola, it is coming up, 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 and then it starts to turn right there, and that is at -3, +2. Because this comes up and back down, that's going to be a maximum. Again, think of it like a roller coaster. You'd be going up at the top of the hill if you were where the blue dot was. And then your axis of symmetry, remember, is always x equals a number, and it's always the x value of your vertex. So it'd be x equals -3. Like that. Okay? So for example 2, we are going to put the quadratic functions in order from widest to narrowest. So looking at the equations, f of x, equals -4x squared, f of x is 1/4 x squared, and f of x is x squared. F of x equals x squared. Remember, f of x is just y. That is going to be our middle ground because that is our parent function. Then, thinking that we want a wider number, remember this is backwards from what you would expect. Wider means that the number is smaller in front of the x squared. So we would have f of x, I guess it's going to go on the left. So we would have f of x equals 1/4 x squared because that's the widest one. And then our narrowest one would be f of x equals -4x squared. Boop. And that would be narrowest. There we go. Okay, and again, you're just looking at the number in front of the x squared. So for example 3, making a prediction about the graph, thinking about how it's going to open and what its width is compared to the parent function x squared. With y equals -2x squared, because of this negative sign, that tells me that it's going to open down. And then because this number 2 is bigger than 1, I know it is going to be narrower than x squared. Okay? Now, if I have something in front of it, like 1/5, remember that because it's positive tells me that it opens up. But then because it's 1/5, that's a fraction, so it is going to be wider than x squared. And then last but not least, with this minus 8, that minus 8 tells me that it shifts down 8. Okay? So, looking at a real-world example, a child drops a pebble from a height, oh goodness. A child drops a pebble from a height of 75 feet above a lake. The function h of t equals negative 16t squared plus 75 gives the height h of the pebble in feet after t seconds. So first we want to graph the function using a table of values. T is time, and so that's going to be our x-axis. And then our y-axis is going to be its height. Is 15. So we will just count by 15. So this would be 15, 30, 45, 60, 75. And so then our time will have 1, 2, 3, 4, 5. And so for our table of values, I'm going to go ahead and just plug in 1, 2, 3, and 4, and 5. That way we can see what ends up happening. So we'll pull out our calculator. We would have t squared would be 1 squared, so that's 1. So then 1 times negative 16 would be negative 16, plus 75 would give us 59. Then when we do the same thing, t squared at 2 would be 4. So 4 times negative 16 would give us negative 64, plus 75 is 11. My 59 looks funny. Okay. Then when we plug in 3, 3 squared is 9. Oops. So then 9 times negative 16 plus 75. And by the way, the parentheses are so that it does the 9 times 16 first, or negative 16 first. And that gives us negative 69. And my graph doesn't even go into the negative, so I'm not going to bother with those. But when I graph the points, and I guess technically I should have plugged in 0, because if I plugged in 0, then I would be at 75. So I would be right up here on the y-axis at 75. Remember, if you need the y-intercept, you can just cover up your variables and your constant is your y-intercept. But then at 1 second, it's at 59, so it's just below that first dot. And then at 2 seconds, it's at 11. And then by 3, it's already like way down low. Okay? So, at about what time does the pebble hit the water? Well, it hits the water a little after 2 seconds. So, about 2 to 3 seconds. Okay? And then how far has the pebble fallen from t equals 0 to t equals 1? That is from 75 to 59. So, 75 minus 59 would give us 16. Okay? And that would be 16 feet. And so then looking at, does it fall the same distance from t equals 1 to 2 as it does from t equals 0 to 1? So the way to look at this, t1 to t2 would be this section right here of the graph, and t0 to t1 would be this section of the graph. So just by looking, you can see that it has not fallen the same distance. It falls faster, or it falls farther between 1 and 2. Okay. And so then our closure question, in a quadratic function, y equals x, oops, word is special. So for our closure question, y equals ax squared plus c, how do a and c affect the graph? Well, a is, remember, the number in front of that x squared, so that if it's negative, tells the graph that it opens down. If it's positive, then the graph opens up. Then the part that's kind of backwards about A is that if it is bigger than 1, it is going to be narrower. But if it's a fraction or decimal, so less than 1, it's going to be wider. Okay, and then C is really your y-intercept, and it tells you how far up or down the graph shifts. Okay, so that is the end of just the beginning of quadratic functions. You're going to be doing a whole bunch more with them beyond this, but this is just the start. So if you have any questions, just comment below, and if this video is helpful, give it a like and subscribe to the channel so that you get notifications when we make more videos. We will see you later.